Hi there, everyone. Kathy's the Managing Editor of Solar Power World here, and welcome to today's webinar, Critical Connectivity, Addressing Site Communication in a Wireless and Sometimes Wired World. So today there's a wide variety of choices for linking the gateway to routers, but today we're going to try to help you understand some of those options and so you can know the best solution for your project. And before we begin, we'll just go over a few house cleaning items. This webinar will be available after the presentation on solarpowerworldonline.com, and it is emailed to all registrants, so you can view it again at your convenience. I know a lot of people ask that, so you will get a copy of that. And there'll also be a question and answer session at the end of the presentation, which is a good way to pick our presenters' brains. So we encourage you to participate in that, and you can just submit your questions at any time in the Q&A box. And then we do encourage you to tweet along with us at #SolarWebinar. And at this time, I will introduce our presenter. Today we have back Chris Barrett. Chris brings more than 20 years of experience in the solar and semiconductor industries to lead AP Systems customer service. He previously worked as Technical Services Manager for SolarBridge Technologies, directing a multinational call center that monitored global PV installations, provided support, and dispatched technicians to the field. So Chris is a great source of expertise for us, and we're excited to have him here today. So go ahead whenever you're ready, Chris.
Kathy, thank you so much for that tee-up. I really appreciate it. Hello, everybody, and thanks for joining the call today. Looking forward to sharing with you my lessons learned on internet connectivity over the last quite a few years of connecting, like you said, gateways to the internet. So let's dig in a little bit here. Slide. Okay, so today I really want to talk about the internet connectivity challenges that we all face in the solar industry today. And I want to really dig into basically the 5 different, or what's called common methods that installers today are using to connect to the internet. I also want to talk about making the right choice for you and your business, and then talk about just kind of a conclusion as far as what's the right thing for you to go forward. First of all, for those of you that are not familiar with AP Systems, I just want to just quickly review. So we actually are the #2 microinverter supplier in the world, and #3 MLP supplier in the world. We are headquartered in beautiful, rainy today, unfortunately, Seattle, Washington. And I just wanted to mention that our tech support team is US-based right here in Seattle. Okay, I'll start the presentation off a little bit with some questions for you. I guess these are questions that I get all the time. You know, do you spend time dealing with internet connectivity issues? I think that majority of you would be shaking your heads or saying yes right now if I could hear you. Do you get calls from your customers about systems not producing power when you know that it's an internet connectivity issue? And I think I can see a lot of nods and here's lots of yeses as well. And in everyday life, are you out there trying to help customers configure their networks? I think the last line right here just says it all. You're the solar installer, not the IT guy, right? So those are questions to ask yourselves. And I'm going to kind of dig into some of the common issues. I guess the big question is, do you want to be the IT going forward? As we all know, all the new solar systems today are all internet connected, so we can have remote data. It's essential for today's PV systems. But it involves a lot of communication back and forth between the gateway and the internet. The bridge, or what I'm calling the bridge between the gateway and the internet, is often the most overlooked piece of this puzzle. Let's dig in a little deeper. As we all know, there are many different types of talk we're going to talk about today. There's 5 in particular that I'd like to review in detail. And some of these are things you're hearing things like Wi-Fi, point-to-point, power line communication, Cat5, Cat6. We're going to dig into the strengths and weaknesses, the pros and cons of each of these devices as we move forward through the presentation here. This particular device is what we call a Wi-Fi booster. You'll hear it called different names: Wi-Fi boosters, universal Wi-Fi range extenders. These devices are basically a device which will piggyback on an existing Wi-Fi network and increase the area or coverage for the devices. It will basically create a larger Wi-Fi network and create a bridge so you can connect your gateway to the internet. The next slide is actually a very good pictorial of, on the left side, with a Wi-Fi booster and without a Wi-Fi booster. Let's say, for example, you are going to install a gateway on the right side of this house. With the Wi-Fi router that's in the home, your range is not too far, and you may have dropouts, which is a major issue for something that you want to have running 24/7, 365 days a year. With the addition of a Wi-Fi booster, extender, repeater, you're basically increasing the Wi-Fi coverage of that home, getting the signal across the home to the existing router to use the Wi-Fi in the home. Another choice that we've used in the past is what we call power line networking, or power line adapters, or Ethernet-over-powerline. This is a device which can be plugged into a customer's existing wiring in the home, electrical wiring. This is running over the 120-volt lines in the home. This requires two of these devices, a pair basically, from plugging in from the router, and a cable that plugs from the router to the power line device, running through the power lines in the home to the second device, which is located adjacent to or near the gateway. You can see here, essentially it's a hardwired connection. So what you're basically doing is you're taking an Ethernet connection out of the router into this device. This device then translates that information, pushes it over the copper wires in the home, runs through the home to the other device, and then brings it back out at Ethernet into the gateway. One of the problems with this method here is noise on the lines. Some homes, some businesses especially, have lots of noise on the lines, so which this signal could be interrupted. This is an issue that with this particular device, not applicable in all cases, but something to be concerned about or think about. The other piece of this puzzle is it includes a pair, so these two need to be synchronized, and sometimes can be challenging to make those synchronizations, depending on which line you're in the home these are on. Some devices require to both be on the same phase. Some will actually run on single or both phases in the home. The next method I'd like to talk about is 3G, 4G cellular modem data. This is becoming more and more popular as the years go by. One reason is actually very simple. If you have signal, it gives you ultimate flexibility. If you have a signal from a Verizon tower, a T-Mobile tower, Sprint tower, all it will require, and the example that I show here is actually a T-Mobile portable router. This is a small little device, $35 off the shelf. You can go to any one of your cellular providers. They will sell you a USB dongle, or I guess they call it a modem, USB modem. That would plug into this device. This device then would have Ethernet port out, as you see there in the front, to go into your gateway. This particular device is good for ground mounts, remote locations. or one that we're seeing a lot now is for leases and also for corporate networks, companies that don't want the solar system running to or connected to their network. So good for security. One of the downsides, and I think it's actually minimal downside, but what we're finding is a lot of people that have gone or chosen this route, it simplifies the installation for the installer. And for the homeowner, what will basically happen is, I know, for example, for our company, we have molded many of these dongles deployed, and it's a $10 adder per month on a standard cell phone connection plan. So relatively cheap. Very fast, very reliable, and like I said, the only problem is this ongoing monthly cost of $10 per month. So probably in volume, that cost would go down, but in a one-off case is $10. The next method that we use quite a bit is a point-to-point Ethernet connection. This is actually broadcast over TDMA technology, basically an old cell phone technology. We actually recommend and use a product by a company called Ubiquiti. It's called a NanoStation or AirWire. Basically, this particular device is nice because we're able to actually go span long distances. So we're using the existing home router, and then we're using these two devices. They're paired again. One has to face the other, so it's basically a line of sight. But these products are nice because they range anywhere from hundreds of meters to 5 miles, depending on the distance. Typically, you're not going to have a solar installation that's 5 miles away from the router. But in this particular case, it's nice to have that kind of flexibility. One of the problems with this particular technology is cost. It's a higher buy-in cost. It requires power on both ends. It also requires line of sight. It can be costly. Like I said, to buy in is about $250. But perfect for ground mounts, remote locations, barns, agriculture, these kinds of things where you're not going to have internet service. You don't want to pay for a $10 adder for cellular service. You can use the home's existing or the business's existing router and just extend that to another building very easily. This right here, this slider here, just a quick example of, like I said, requiring power on both ends, line of sight between the two devices. This also does require synchronization, which in this case is fairly easy. It's a quick push button setup. The next and last method of connection, and probably one of my favorite, like the presentation says, it's not the sexiest in this wireless world that we live in, but it is the cheapest and most reliable. One thing that a lot of people like is it's actually a very secure connection. You can make your own connections, or you can buy pre-made lengths of wire and keep it in the truck. This particular method, as I said, is very cheap. I've had many customers tell me before, well, Chris, it's very difficult for me to run the wire to the customer's router through the home, through the attic. It's going to take me an extra hour, extra 2 hours on site. And I asked the question, I said, well, how much does it cost you when a customer calls and says, I've got a problem with my system, it's not producing power, and you know that it is. I had a customer in Hawaii that did this. He always put in Wi-Fi repeaters, and in the Wi-Fi repeaters would always drop out and fail. He would have to come across the island to go fix reset a router or reset a Wi-Fi booster, only to go back a few days later to do it again. I asked him, I said, why don't we just go to the Home Depot, we'll get a spool of wire, we'll get the crimpers, we'll get the cutters, and we'll run the wire together. And he says, that's going to take a long time. So it did. We went down to the Home Depot, we bought the equipment, we bought a spool of wire for $50, we bought a tool for a crimper for $40, So out of the gate was $100 of purchase, one time for the tool, a few connectors. Went over to the house, ran the wire, set everything up, never heard from the customer again. What was interesting, though, we heard from the customer's neighbors about how happy he was with the system and how they wanted to actually install solar. So this is actually just an interesting model that we have used with success, great success. Like I said, I know a lot of installers say they don't want to run the wire, they don't want to take the time, but I guess, like I said, my question to you is how much value is a happy customer? We'll go into that as we go forward here. I say on here, it's like I said, it's a single cable, one end to end. You can make your own cables, you can buy your cables. I say on here pros, no IT calls ever. That may be a bit of a stretch because I have had a couple calls where customers have done what I've asked in regards the wire. They said, my system's not working. And come to find out that someone in the family had actually unplugged it and plugged in their Xbox into the router. So like I said, it's not foolproof, but it definitely, like I said, is the fastest, most reliable, cheapest, most secure method out there today. So making the right choice. Like I just kind of articulated this a bit. Solar customers really want reliable modules. We were all asking for that, right? 30-year warranties. Reliable inverters, where everybody wants a 25-year warranty. Reliable power production. Of course, we want to make as much power as possible. And like I said, it's just time to ask the installers, what about reliable internet connectivity? And like I said, I'm giving you 5 different options today that we recommend to our customers. Our number one call volume thing is for internet connectivity issues. It's not about the inverters. It's not about installation. It's not about electrical connections. It's about internet connectivity. So out of the 5 solutions that I presented today, the best solution is the one that requires the least follow-up for you once you leave the job site. That's really what it comes down to. And like I said before, the only call you want from is a happy customer asking you for more solar installed on their roof or their neighbor. And I guess in conclusion, I just want to say, like I said here, the best salesperson in your company is a happy customer. Happy customers tell their neighbors about your products and services, and no to low truck rolls save you time and money. You don't make money going back to the job site. I'll open it up to any questions you guys may have.
Thank you so much, Chris. That was some great information. And we do have some questions coming in. You can continue to submit questions in the Q&A box on your screen, and we'll start beginning with some of those. So what method does AP Systems recommend for internet connectivity? I know you've kind of gone over some of them.
Well, like I said, I'm a bit jaded. I do like the hardline wire the best, just simply because it is the lowest cost solution. When you look at material cost, the example that I gave for the Hawaii site, we ran about probably 60 feet of cable. We crimped on 2 connectors. So the actual material cost was about $10. The tool, it's a one-time cost of about $40. So, buying cable in bulk, connectors in bulk, having it on the truck ready to go, you can make a custom solution for each of your homes or businesses. So that I would say that's the best. If I had to pick a second, I would say either the cellular or PLC communication, both very reliable as well. But just want to keep in mind that all the solutions that I talked about, the range extenders, we still require a wire to go from the router to the range extender, and from the range extender to the gateway. If you use the power line adapters, same thing. There's still a wire involved. And even with the cellular connection, you have a cellular bringing in internet to the device, but then you still have an Ethernet cable going from the device to the gateway. So no matter what, you're using a wire, whether it's short pieces of wire or one single long piece of wire. And like I said, you're guaranteeing these systems. I'm sure most of the installers today have a 10-year warranty on their workmanship. So a two-hour adder at each home to install the hard wire will reduce the number of truck rolls, phone calls, and possibly, even like in the Hawaii case, increase your business by satisfied customers that are telling their neighbors about it at dinner.
Awesome. Thank you, Chris. Another one we have here is, what is the cost like to have a standalone cell modem if you can't add it to an existing cell account?
If you can't add, that's a good question. That would be definitely dependent on each provider. I've heard of customers that can go and just get a simple data plan with this for $20 to $25. I know that's true through Verizon and through T-Mobile. I'm not familiar with the pricing for Sprint or for our AT&T.
Another one is, how do you connect the ECU's built-in Wi-Fi to a customer's Wi-Fi router?
Very simple, actually. So the ECU has a built-in router, basically. So it is actually what I would call a hotspot. We call it a local wireless access. And what you would do is on your mobile phone, you would actually be able to connect to the device directly. From a mobile phone, a computer, a tablet, whatever. You would just search out or seek out the SSID ECU-Wi-Fi _ and then the last 4 digits of that SSID would be the last 4 digits of the serial number. You would then type in the IP address of that device, which would be 172.30.1.1. An automatic interface, the AP systems interface, will show up on your phone, tablet, or computer. From there, you'll be able to actually search out or seek out the homeowner's SSID, select it, type in the password, and then hit OK, and then the ECU will then be connected to the homeowner's network, Wi-Fi network.
Excellent. Simple as that. Someone else is wondering, how far are you finding the gateway will pick up the microinverters through the PLC?
Oh, actually interesting. So yeah, this particular PLC that we use, we have it's a theoretical max range of 5 kilometers. So that's about 3.5 miles. But saying that, that's in a straight wire with no interference at all. Within the homes, we're finding that the PLC can go quite far. We have quite a few customers that use this in a ground mount situation that are going hundreds of feet with no interruptions. So yeah, we've run into cases before where we actually pick up neighbors' units, neighbors' inverters, going back through the transformer back over to their home in solar dense neighborhoods. So quite far.
The next question is about cable length, and the person says, thank you for the presentation, so they must have enjoyed it. And they said, what is the maximum recommended cable length of the PLN option you described?
Maximum power line, well, that goes through, that again is probably up to 100 meters would be like what they recommend for a reliable. But we've seen customers that do over 300 meters on distance.
And about how long does it take to install the custom Ethernet cable?
That really depends on the home, and it depends on the job that you're doing. If you do it like a cable installer, you'd get a long bit and drill a hole right through the wall and into the outside wall into the inside wall. To be able to take it and fish it through a wall and bring it up into the attic and bring it down through a wall, it really depends on aesthetics and what you're willing to do for the customer. How long, if you want to put a plate in, a box, low voltage boxes, hard to estimate. But my experience has been anywhere from 1 to 2 hours, depending on the configuration of the home. Like I said, some homes, and I get it, some homes are very difficult to get through. You're talking about brick or plaster or different configurations or low ceiling heights. Maybe very difficult to do this. So that's why we have other options. But So if the option is available, if there's some kind of crawl space that can come up through the floor, it's always the best choice.
Great. We still have a lot of questions coming in, so I'm kind of just shooting these at you. But this
Sure.
one is wondering about, when you have a connection kind of in the middle of nowhere in a remote location. They ask, do you have any recommendations for extending or strengthening the connections when you're in the middle of nowhere or remote location? They said they have a newer AT&T model, MiFi pass, and they struggle to keep the connection for more than 5 minutes.
Oh, interesting. Well, then I would definitely, it really depends on the signal strength, of course. But also what I've found especially with Verizon, is to update the towers. A lot of times on the GSM networks, that happens automatically. But any kind of CDMA network, like Verizon, I find that you have to actually go manually update the tower so that it's actually talking to or looking for. So maybe it might be something to talk to Verizon about. A lot of times, like in the phones, it's like I guess it's called a preferred tower list, PTL. Sometimes located in the phone or maybe even the MiFi as well in the software.
Excellent. I know there's a lot of installations that are out in remote locations, so that was a good question. In a big commercial application, you have a lot of electric panels in one area, and so you have routers 250 feet away. Where would you install the gateway?
Well, I mean, it depends on, so if it's a commercial environment, it depends on which product you're using of ours. If it's PLC, I would say as electrically close to the array as possible, because to avoid any kind of electrical noise in the lines, especially in a factory, corporate kind of environment. If it's Zigbee, that's all over through the air. So we say within 100 meters of the device, to the first inverter to the gateway.
All right. Another one is, do you have common issues with using the cellular modem? I've seen these frequently go into sleep mode, and the ECU is then unable to automatically obtain a new IP.
Yes. So in the portable router itself, that is actually a setting that would actually be set. So the ECU goes through and pushes data out every 15 minutes. So depending on the router settings, of course, you would have to tell it to keep awake, stay awake. If it's not seeing any data, a lot of times it will fall asleep to wait for data.
Have you ever run into bandwidth issues using the routers of high bandwidth customers, people that maybe watch a lot of movies or game or things like that?
I have not, because the amount of data that we're pushing up is kilobytes. It's really minimal amount of data every 15 minutes.
Are there some power quality requirements for power line communication between the ECU and the microinverters?
Say the question again, sorry?
Are there any type of power quality requirements for power line communications between the ECU and the microinverters?
Ooh, I guess it's a very vague answer, but we were looking for clean power. We're not looking for, just standard everyday grid power is fine. What we do face, and we face it with communication for PLC, is noise. Any kind of noise injected on the lines from machinery. We're seeing a lot from LED lighting. These kind of things will throw a lot of noise on the line and change the profile of the grid. Will make it difficult for the PLC to communicate from the gateway to the inverters, or even for that case, we're talking about this Ethernet-over-powerline. The power line adapter, same thing. That also will be thrown off or have difficulties getting through.
I think we have time for a few more here. Someone's asking if microinverters can be used for 1500 volt panels.
1,500 volt panel. So, well, sure, because I mean the microinverter itself, or the panel itself, is only giving off 35, 40 volts in most cases. I mean, it depends on the size of the panel. It also depends on the inverter as well. So we have the two different models, the YC500A, 500I, and then also YC1000. So we can put up to 55 or 60 volts in either one of those, respectively.
Okay. Is there a particular number of modules that you can connect to the same ECU simultaneously?
Yes. So we say it's a 200 inverters for a YC500 installation, or 100 inverters for a YC1000. So that would equal 400 panels for 500, or 400 panels for a 1000. Because the YC500 is a 2-for-1 inverter, and the YC1000 is a 4-for-1 inverter.
Got it. Thank you. I think we have time for maybe one more here. Someone's wondering what is the best way to plan for internet connectivity issues during the initial site visit?
I think that's actually a great question. I think that's actually something that should be part of the initial checklist. When you go in and talk to the homeowners about their system, their requirements, their needs, I think one of the things that you should add to everyone's checklist is what is their internet connectivity, who is their provider, take a look at their router. I'm finding that a lot of installers today are throwing in, or adding in, maybe is better, to the package or the quote, is a new modern router. We're finding a lot of people are having these routers that are 5, 10 years old, and having issues during connectivity during commissioning. To avoid that completely, they're actually asking the customers to either call Comcast and upgrade their equipment, or if they have their own equipment, maybe either have them upgrade it or bring along a new router or switch. But add that to your checklist of things to look at. So you're looking at the roof, you're looking at the configurations, you're looking at the electrical panels. Add in internet connectivity checklist.
Excellent. Okay. Well, I did also want to add, we had someone from Sprint reply on the remote connectivity question too, and they said that the best improvement from them would be for spotty signal strength is upgrading the antenna to a higher gain antenna or directional. So just some tips there.
Great.
Yeah. But yeah, thank you so much, Chris. This has been great, and we appreciate all the wonderful questions. Made for a really great discussion. And if you weren't able to have your question answered, you can also contact Chris on your own. But thank you again, Chris. Great information. We appreciate it.
Absolutely, Kathy. Thank you so much for everything. I appreciate your time and everyone for joining. Like I said, if there's any additional questions, please feel free to send me an email, and I'll be happy to follow up.
Awesome. And again, this webinar is going to be emailed to all registrants, so you can view it again at your convenience. And thanks again to everyone in our audience for listening and your questions. And I hope you enjoyed the presentation, and we invite you to join us for more Solar Power World webinars. We have a lot coming up. So thanks, everyone.
Thank you, Gabby.